Question 3. Question about enthalpy changes, and it wants us to calculate temperature rise. So for these type of questions, I always like to write down all the formulas we could possibly need. Q equals mc delta T. Delta H equals Q divided by moles. Moles equals mass of MR. Moles equals concentration times by volume. 1, 2, 3, 4 equations. But hopefully you know all of these off by heart. So we are trying to find the temperature rise, delta T. Now we can rearrange this equation. Delta T equals Q divided by MC. Right? How do we find Q? Well, we can't use Q equals MC delta T because we don't know delta T. We have to use this formula. Delta H is Q over moles. Therefore, Q equals delta H times by moles. Delta H is 56 minus 56.1 kilojoules, so it's gonna be 56,100 joules. We obviously don't care about the negative sign. Times by the moles. Well, we need to find out the moles. Let's find out the moles. As you can see, the same volume, same concentration, so it doesn't matter which one we find the moles of, we're going to get the same number of moles. So let's just find out the moles of aqueous sodium hydroxide, NaOH. Just show how we get there. Don't just put in a calculator. 25 divided by 1000 because centimeters cubed to moles per dm minus cube times by 2.0. That'll give me 0.050 moles. So now we can say Q delta H is Q of moles. Q equals delta H times by moles. What I've done is rearrange it times by moles. Moles is 0.050. Therefore, Q is equal to 2805 joules. Remember, Q is measured in joules. Heat energy released in joules. So now what we're trying to find is delta T. Well, delta T equals Q 2805 divided by MC. Well, what is M and what's C? Well, C is specific heat capacity 4.18 in joules. M in Q equals MC delta T. And all we've done is rearrange it for delta T. M is the mass of water. That's really key. Does it give us a mass of water? No, it doesn't. However, it tells us that assume both solutions at the same initial temperature have a density of 1 gram per centimeter cubed. So total number of solutions 25 centimeters cubed plus 25 centimeters cubed, 50 centimeters cubed. But we know it has 1 gram per centimeter cubed. Therefore, that 50 centimeters cubed, we can assume that it's 50 grams of water. So it's going to be 50. That's the mass of water times by 4.18. 2005 divided by 50 times by 4.18, I get delta T equals 13.42 degrees Celsius. 13.4 degrees Celsius. That's my final answer. So probably 1 mark for this, 1 mark for calculating the moles, 1 mark for finding out the mass of water, and then a final mark find out the temperature rise. A bit slightly tricky, but just become very confident with these formulas, being able to rearrange them and your units, and it makes these type of questions a lot easier. Obviously you still need to think a bit, but once you've got the units and the formulas already written down and you know how to convert and you know how to rearrange your formulas that you need to know by heart, it just makes the rest of it a lot easier. And then 3.2, draw an appropriate best fit line on figure 2 and use it to find the temperature change at the time of mixing. Okay, it's a bit of a tricky one. But we know at the 4th minute the student added sodium hydrogen carbonate. Student stirred the mixture carrying student measurements shown in figure 2. Okay, so we can see already here that these points can give me a really smooth curve just off the bat, and that is actually the best fit line. So that's already done. And then use it to find the temperature change at the time of mixing. Well, the student added the sodium hydrogen carbonate at the 4th minute, and once you add the sodium hydrogen carbonate, you're going to have to mix it with the ethanoic acid in the polystyrene cup. You can't just leave it in there, you have to mix it, and therefore the student mixes it. The temperature change at the time of mixing is at the 4th minute. And if you just look at the 4th minute, obviously you're not supposed to draw the straight line on the graph, but that's at the 4th minute, and that will give me that's the temperature, which is 17.2 degrees Celsius. Because if you're adding sodium hydrogen carbonate, you're going to have to mix it with it, and therefore that's going to be at the 4th minute, because that's when you're adding it, and therefore the temperature change at the time of mixing is 17.2 degrees Celsius. And that is the end of question 3.